class that you took yesterday, which was all about matrices, there was a question that said define matrix, right? It had been on every practice test. And you know what? 2 people in this class missed it.
Was I one of them?
Now, that is, I almost said stupid, I'm trying to be nice here. It is ridiculous to not know the definition of the thing the whole chapter is about when it was on all 3 practice tests. So here's the definition that you are going to learn. A vector is a directed line segment. 3 words. Directed line segment. Vectors have 2 qualities. They have direction and magnitude. Does anybody know, this is another vocabulary word, magnitude.
Magnitude.
Does anybody know what that means? Physics students, magnitude, what's it mean?
That's all it is.
It means length. If you are a vector, you have direction and magnitude. You have direction and length. Okay? So, when I look at problem, okay, that it got cut off. Problem number 1, please mark it so that it looks like this. It should have that thing over the top. I don't know what happened to it. Got cut off somehow. That had that little vector symbol over the top of it. And the 2 points that you've been given are -1, 2, and 3, 4. Now, a vector describes a movement from point A to point B. So this is so easy. You look at the 2 points and you say, okay, I'm going from -1 to +3. How many steps is that from -1 to +3? That's 4 steps. Is it 4 steps in the positive direction or 4 steps in the negative direction? So we'll say the first coordinate is 4. Yep.
Just the thing next to the 4. I can't remember what's that called.
What?
Is that supposed to look like a V?
Your book kind of uses this symbol for a vector. I get lazy sometimes and just put a parentheses. It doesn't matter. Now, we did the X's. Now we're going to do the Y's. We're going from 2 to 4. That's 2 steps, right? Positive or negative? Positive. There are the coordinates of that vector. The vector from A to B moves like this. In other words, in order to get from this point to this point, you go right 4 and up 2. That's all a vector does, is tell you how you move. So let's look at the next one. Gibran, who signed this?
This is Father's arm.
All right, let's try the next one. The points, I guess you had the definition, so I can erase that. The points are 2, 4, and -1, 0. And we want the coordinates of the vector from A to B. So here we go. We're going from A to B. So look at the X's. We're going from 2 to negative 1. How many steps is that? 3. That's 3 steps. You guys, don't make this hard. For Pete's sake, here's the number line. Here's 2, here's negative 1. How many steps is it to get from here to here? 1, 2, 3. Right? Positive or negative direction? Negative. So that's a negative 3. Now, from 4 to 0, that's 4 steps. Positive or negative? Negative. So this vector tells us that to get from point A to point B, we have to go left 3 and down 4. A vector just tells us how we move. All right, let's look at the next one. All right, how do we get from point A to point B? That's what we're trying to figure out. We're going to get from point A to point B. Negative 3 to positive 1.
4. Everybody
okay with positive 4? Going from negative 3 to positive 1. How about from negative 6 to positive 4?
10.
That's 10 steps.
Eyebrows on.
Okay, do that last one by yourself. See if you can come up with the coordinates of the vector from A to B. Anybody want to share? Abby? 6 comma 1 is exactly right. We're going from 0 to 6 and from 1 to 2. So, if you were to walk in tomorrow and I said, get out a half sheet of paper, here's point C, and here's point D. Find the coordinates of the vector from C to D. You would be able to do that. 5 to 1. Negative 4 to 5. Everybody would be able to do that. All right, let's see. Maybe we can come up with another quiz question. Let's look at number 2. Number 2 says, okay, now we've got more points.
Yeah, so's a banana. Doesn't smell like that either.
And we are going to figure out if AB is congruent to CD. We don't know if it is or not, or equal to. Is AB equal to CD?
Yes.
Now, some of you are saying yes. Well, how are you figuring this out?
If they have the same distance.
Exactly. So we find the coordinates of both of these and then see if they match. So from A to B is what? From A to B.
Oh, 5.
5, negative 2. From C to D.
Uh-oh.
5,
Uh-oh.
negative 2. The answer to the question is yes. The only way they will be equal is if these match exactly. You can't have part of it matching. You can't have it be negative. The whole thing has to match exactly. Okay? So let's try the next one.
No.
We're going from negative 3, 1 to 0, 2, and from 4, 1 to 6, 4. All right, so what's AB going to be? gonna be 3, 1, good. What's CD gonna be?
2, 3.
Uh-oh,
Not the same.
not the same, so the answer is no. They aren't equal.
Wait, this board. Why on the top are the parentheses like that and then
Okay. Your book uses this notation. Other books use parentheses.
if we use parentheses are we gonna get points off? I'd rather do parentheses.
So do you just say yes and no if it works? Say
Yep.
yes, it works.
Yep,
I like it when you call me Big Papa.
okay. Now, number 3. Find the components and magnitude. There's that word. What does magnitude mean? Length.
Correction.
Find the components and length for PQ. Now, you have already figured out how to find the components. These right here, boys and girls, are the components. This is the components. Whether you use the diagonal things or the parentheses is irrelevant. Don't care. Doesn't matter to me one way or the other. Your book uses this. You'll see I always use parentheses. Don't want you to be confused about that. Does not matter. What matters is that you get the right numbers in here. So we're going from P to Q. All right? What are my components? 1, 1. Everybody okay with 1, 1? Now, I want you to visualize a vector that moves over 1, up 1. That's what this does. It goes right 1, up 1. So the easiest way for me to draw that is to just start at the origin and say, there it is. That's the vector, or a vector. There's tons of them. But that's a vector that goes over 1, up 1.
So just plot it.
Yep, just plot it at the origin, go over 1, up 1. Perfect. Now, I would like to know how long it is. I want you to think about something for a minute. Let's make our butterfly bow tie.
Butterfly bow tie.
Everybody's like, duh.
So we're going over 1, up 1.
Yo, that was a really bad time in my life. That whole butterfly bow tie.
So how long is that? Okay, somebody said it's a 45-degree angle, which it is, and that'll be important at some point, not right now.
I think you're talking to a ghost. I didn't hear anyone say 45.
How long is it? Root 2. Now, that happens to be a special triangle, 45, 45, 90. That's irrelevant. To find the length of the vector, couldn't we just do the Pythagorean theorem? And that's what we'll do every time. So the magnitude of this vector, you're going to want to see this, the magnitude of the vector is PQ, or is a root 2. And the way I write that is like this. I put it inside absolute value. This is the notation that means magnitude. When you see something in a vector, when you see a vector inside an absolute value, it means magnitude. And magnitude means length, and we'll find length by doing the Pythagorean theorem. All right, let's try the next one. All right, so we're at -1, 0, and 6, 1. Step 1, find the components. Maya McLaurin. We all know how to find the components. Let's see, what will they be?
What she just said? Diner, Decker.
7, 1. Everybody okay with 7, 1? Now we need the magnitude of that. So I'm gonna draw a picture of it. This one goes over 7 up 1. This is its magnitude, kids. That's how long it is. This is the vector, over 7 up 1. Right there it is. How long will it be? 7 squared plus 1 squared. That'll be root 50, which is 5 root 2.
Okay, you know what? I'll stop paying attention for about 3 minutes.
Yep.
I come back to
And I do
this.
not feel sorry for you.
It's alright, we got it recorded, Probably
Okay,
won't
let's
watch
try
it.
the next one.
so we got it.
Why don't you just watch this now?
Ooh. Got to slap me. Turn around and backhand me.
All right, so we need the coordinates of the vector. Katie and Abby.
I think they have that one.
You should go over there and slap her. Slap her. Oh, it's cops yesterday. You should slap her.
What is Katie Baumgartner? Tell me the coordinates of vector PQ. You're going from P to Q.
-6, -3.
Okay, I'm going from -7.
7. Oh, 7.
That would be 7. And then I'm going from 2 to -3. There you go. Now see, Katie, if you just think about it, you can do it. Don't just blah, blah, blah. Think about it. Now, I need the magnitude of that vector, so I'm going to draw a picture of it. This one goes over 7, down 5. When you do your Pythagorean theorem, people, the negative squares out. You're never going to have a negative. So this is going to be the square root of 49 plus 25, which is the square root of 74.
Can we just leave it like that?
Jabron, stop it.
I'm sorry.
What are you going to do with it?
You have to break it down.
It doesn't break down. It's 37 times 2. If it breaks down, you need to break it down. Okay, let's do one more of those. Let's see, which one was that? All right, so here we go. We got -2, 4, 2, 6, 1.
Wait, Miss Ford,
Yep.
would it matter if you put 2 root 37 for
It's
that?
not 2 root 37.
My fault, never mind.
It's the square root of 2 times the square root of
It's alright,
37.
baby. It's alright.
So
Mama
yes,
still
it
love
would
you.
be wrong.
Okay.
All right, what are the coordinates of vector PQ? 8, -3, you're right. What is the magnitude of 8, -3? It would be the square root of 64 plus 9, which is the square root of 73. Okay. Now this looks a little bit different.
It's a little more intense. A little more intense. We got different letters and everything.
All right, so everybody's turned the page. Everybody's turned the page. And we are now looking at some vectors.
There used to be a video game called Vector. Now after doing this,
Now, the first question
Despicable Me.
says we want to add vector u and vector v together. Now, I have not taught you how to do this,
Not yet, at least.
but you can take a guess and you would be right. If this is u
Just take
and
it
this
now.
is v,
Get it back.
anybody want to take a guess what the sum is?
-1, negative.
-5, Olivia.
Negative
-1. You are right, Olivia. Tell us how you did that.
How you do that?
Then add the y.
You added the x's and you added the y's. Groupies, it could not be easier. You add the x's, add the y's. Taylor.
The first two is like negative on
What?
Oh, that's negative 3.
Oh, I'm sorry. I'm sorry. I copied it wrong. That's going to change this.
I was right.
That would be -1.
Wait, what you talking about?
I copied the problem wrong. So I just fixed it. So the x's add together to give you -1, and the y's add together to also give you -1.
Okay, okay.
Thank you, Taylor. All right. B. Oh, by the way, new vocabulary word. When we add vectors together and we get an answer, we call the sum
Twerk fast.
the resultant. So when you hear the word resultant, whoever's saying that word to you is talking about adding vectors together. The resultant is the answer you get when you add vectors together. So if I say find the resultant, I'm asking you to add.
Okay, I see.
Resultant means add.
I see what you did.
The sum of vectors, the sum of two or more vectors. That's exactly right, Jack. Okay. Now, question B. 3V. Alrighty. 3V. Any guesses? Take a wild guess.
Multiply that by 3. You get 6, -6.
6, -6
I'm a
is
wizard.
the answer.
I'm a wizard.
And guess what this 3 is called?
Scalar.
Yes!
That's
The
what.
vocabulary
Bonus
is the
points,
same.
Olivia. Bonus points, Olivia.
And you do the multiplication the same way you do it with matrices. Remember, when we
forgot
put
that
a
on the
3
case.
out in front of the matrix,
I
we
forgot
multiplied
that.
everything by 3?
What? I'm gonna put
When we
coefficient.
put it out in front of a vector, we multiply everything by 3.
Okay, see that changes things.
C. What does this notation mean? You already know that.
Yo, probably.
Well, it's the absolute value notation, but it means what in vector land? Magnitude, length. So we'll draw a picture of vector u, which is over left 3, up 1, right? This is the vector, and I want to know how long it is. So it would be the square root of what? 9 plus 1. The answer to the question is the square root of 10.
Do we have to draw a picture every time?
Nope, you do not have to draw a picture at all. The picture simply reminds me that I'm using the Pythagorean theorem. If you want to do that without a picture, that is fine.
20 seconds.
D, putting some ideas together.
Mm-hmm.
Okay, so I know what u is. U is -3, 1. Now I need to add that to 2v. What's 2v?
4, negative 4.
4, negative 4.
Add that
Everybody
together.
okay with that?
And then 1,
Now I'm
negative
gonna add them together and get the
1
resultant.
tray ball.
And that will be 1,
All I do
negative 3.
is shoot threes.
How do we add vectors, boys and girls? Add the x's, add the y's. I know what you're thinking. Does it get harder than this? Yeah, it does a little bit.
That actually was what I was saying.
E. V minus W. So that's 2, negative 2 minus 0, 3. Anybody have an idea how we'll do this? Just subtract x minus x would give me what? 2. And y minus y would give me negative 5.
Okay.
What do you think this means?
Torque it.
The negative.
The opposite. So what would the opposite of this be?
Trace uno.
3,
Negatory
negative
uno.
1. Perfect.
I don't know negative. Negativo.
Uh-oh. Now G, we gotta be careful of here. What do these absolute value things mean again? Magnitude or length, right? Okay, so I gotta find the length of something. What am I gonna find the length of? Jack?
We should have solved for you. Is it U vector C?
Vector U minus vector V, yep. So first thing we're going to do is the subtraction. Magnitude of the whole thing. So the first thing we have to do is right here. All right, so here we go. What's U minus V going to be? U minus V. That would be negative 5, 3.
Yeah.
Now I want the magnitude of that. So it looks like this when I draw it. So the magnitude would be 25 plus 9, the square root of 34. Did everybody understand those steps?
Mm-hmm.
Okay, and finally H.
So the drawing is going to be unnecessary.
Okay, what'll be the first thing you want to do with H? This is H right here. Multiply U by 2, so that'll be negative 6, 2. And then we'll add W to that. Right? And what do we get? Negative 6, 5. Perfect. Now that's all of this, right? What do we need to do to it? Magnitude. So negative 6, 5. The magnitude will be the square root of 36 plus 25, which is root 61. I have packed in a lot of information. Check something out here. 1,
noises are you making?
Okay, I gotta pack in just a little bit more. Yeah, stay with me. All right, look at the next section. The next section says, we have this vector V. And I want a unit vector. What are you doing? You want to erase that?
Yeah.
I want a unit vector in the same direction as this one. Now, it's unfair of me to ask you this question. I'm going to ask it anyway. Anybody have any idea what a unit vector even is? Yes? What? That's what a vector
Is that when you graph it?
A unit vector has a length of 1. So a unit vector is any vector whose length equals 1. So if you have a vector whose length equals 1, you are a unit vector. Now, let's say my arm is a vector. Its length, let's say, is 5. If I want to make my arm a unit vector, I got to chop it off, right? Because right now it's 5 and I need it to be 1. So I would have to chop it off so that all I had left was 1/5 of it. Right? If it was 5 long and I kept 1/5 of it, it would be 1 long. So what you're going to do